Okay guys, this chapter we're going to start out spherical geometry and congruent and similar solids. And so in the first video, we're just going to talk very, very briefly, just sort of introduce you to the fact that there are other geometries out there besides plane or Euclidean geometry. Okay, so basically all in this course, we've only been dealing with Euclidean geometry. And so what does that look like? Well, okay, so we have a plane. Okay, so we know certain things about lines. We know certain things about triangles, quadrilaterals. We've been talking about all of this stuff. And you might say, okay, Kevin, I'm sure that in geometry, triangles always have 180 degrees. And I would tell you, you're wrong, because in not every kind of geometry does a triangle have 180 degrees. I'll get to that in a second. But some things that we hold as fact, such as a triangle having 180 degrees, that we've proven in Euclidean geometry or in plane geometry, is in fact not true and very easy to prove false in spherical geometry. So spherical geometry we have, of course, is talking about the geometry of a sphere. Now, of course, we have the main, I think one of the big differences is in spherical geometry, we have a line, so we have just a plane, and then we have a line that goes goes between 2 points, right? And so any 2 points, there's only one line that passes between them. That's sort of our definition of a line, going back to our first unit. But here in spherical geometry, it's a little bit different. A line is something that we call a great circle, And so I talked about that a little bit in this course, in this unit, but I want to elaborate on that more. So here's a great circle. So this line here, that is a great circle. So a great circle is by definition a circle. It's a circle that you can take a slice out of the sphere, and it will represent a perfect circle with the center. Here's the key. The center is at the center of the sphere. Okay, so a great circle is a circle that has you can kind of pull out a disk, and that circle would have center that would also be at the center. It would share a center with the sphere. So this is how we define a line in spherical geometry. And so I want to just draw an example of what I was talking about earlier, a triangle. And how many degrees are in a triangle? That's in spherical geometry. Okay, so here's a sphere, and I think a lot of us have a decent idea about spheres because our globe, our Earth, is like a sphere. So imagine you take a line from the North Pole, all right? So you have a line at the North Pole, and you come down, all right? So you're going to come down, and again, this would be a great circle, okay? And then, let's say you go over on the equator. Okay, so you go over on the equator. All right. So I think most people agree from the line that comes down from the North Pole to a line on the equator, that's going to be a 90-degree angle, right? Okay. But then I would argue that, okay, we want to go back up to the North Pole. Okay. And I would argue that this is a 90-degree angle. Okay. And if you make this a quarter of the rotation of the Earth, all right, if you make this angle here a quarter of the rotation, it's possible, this picture doesn't quite show it because I would have to extend this angle a little bit further, but it's possible to have 3 right angles in a triangle. Okay, so in spherical geometry, it's completely possible to have not just 180 degrees, not 200 degrees, not 240, but you can actually have up to 270 degrees in a triangle. You can have 3 right angles in a triangle. In spherical geometry, that is perfectly acceptable. So this is just one thing. We're not going to get super involved in spherical geometry, but I just want you to know that there are many other kinds of geometry that are not just plain Euclidean geometry. All right, there's spherical geometry. There are other types that if you go to university and you're really in love with geometry, you can take a class. And I think when I was in university, we learned about 5, maybe 4 or 5 different types of geometry. And so we went through Euclidean, and then we went back through and we sort of talked about spherical and how that's similar and different with Euclidean geometry. So this is just an example, and really the purpose of this video is just to show you guys that there are other types of geometry. Okay, so we're not going to get super into it. Also, I do want to point out that lines, just another thing that you think about, in planar or Euclidean geometry, two lines intersect in one point. Okay, two lines intersect in one point. But in Euclidean geometry, okay, let me wrap this, imagine this line is a great circle. Okay, so we have that and we have this. Okay, and how many places do these lines intersect? Well, of course they intersect here, but they also intersect back here. So again, two lines in spherical geometry always intersect in 2 points, not one. So just another example, yeah, but again, I just wanted to have you guys see, okay, there are different geometries. Some of the things you take as fundamental truths always are not fundamental truths always. And so this is just a little, two examples, the degrees in a triangle, the number of intersections two lines have. And so hopefully this just kind of opened your mind, maybe struck your curiosity, and you can go on your own and research spherical geometry and look more into that. Thanks for watching.